Hi everybody, I'm Giles Lavelle and welcome back to Python from Scratch, a video series for NetTuts where we're learning all about the Python programming language. This is the third lesson in the series and today we're learning all about functions and modules. In the previous lessons we've downloaded and installed Python and learnt about variables, data types and control structures. So if those aren't concepts you're aware of, then I recommend you go and check out the previous tutorials now to bring yourself up to speed, and then you'll be ready for this lesson. But if this feels about like where you are, then we're ready to get going. We're going to start off by learning about functions, so open up any IDE or text editor of your choice for writing Python, and let's get started. Okay, so I guess a good place to start is defining what a function is. And you can think of functions as a block of code that can be called to run at any time, and as many times as you want. So this is useful if you have a program that does a certain operation lots of times. Instead of having to copy and paste the code to do the operation each place you want to do it, you can simply write a function to do it for you, and then call the function each time you need to do the operation. Functions are pretty much required in order to make large programs. If you try to make a program over about 50 or 60 lines without organizing your code into some functions or other structures, your code is going to become so convoluted and messy that it's going to be impossible to debug or properly develop. So functions make your code smaller, cleaner, easier to read and more modular, which gives you more flexibility in the way you program. So they're pretty great and a tool worth knowing. There are two sorts of functions. There are ones you write yourself and include in your code, and there are ones that are automatically included in Python when you download it, and they're already there to carry out very common procedures. For example, maybe converting an integer into a string, or finding the length of a string. There's no real fundamental difference in the way you use them, it's just that you have to write the ones that aren't included yourself. We're going to have a look at writing a simple function now, and then demonstrate how it can be used in real-world code. And then we'll have a look at some of the most important inbuilt functions and how you can make the use of them. So for an example, let's say you wanted to make a script for a e-commerce website and you had a shopping cart that takes the costs of the items in the cart and then adds them up together to give a total cost. So we'll make a function that can do this. First we're going to need some costs to add up. So just to get started, let's make two variables, call them cost1 and cost2, and give them a number of dollars to represent the cost of each item. So I'm going to create cost1 and set it equal to $15. And cost2 and make that 20. I mean arbitrary numbers just for an example. And I'm just going to save this and I will call it lesson 3. Make sure it's a Python file. Okay, so now we're going to write a function to handle adding up these two prices and also outputting the answer. For now we're going to limit it to having two items just to keep the example simple. So to write a function in Python you begin with the keyword def, which is short for define. And you then need to give the name of your function, and in this case we'll call it SumCart. So let's define a function called SumCart. Then you need a set of parentheses, and I'll explain why you need these later. The final thing you need is a colon, and now press enter. Depending on which editor you're using, you might have noticed that the cursor has been indented. If not, you'll need to add your own indentation by hitting tab. Similar to loops and conditionals in the last tutorial, everything contained within this function is going to be indented one space to show that it's part of the function. So inside this function, all I'm going to do is add up the two costs and then store them in a new variable. Let's call that total cost. So total cost equals cost1 plus cost2. And then we just need to print out total cost. Remember, if you're using Python 3, to put parentheses around the total cost because the print statement works slightly differently there. So let's run this code and see what happens. Save that, and I will open up the terminal and navigate to my documents directory where it's saved, and then I will use Python to run this lesson 3 file. Okay, and you can see that nothing's been outputted. So why is this? Well, that's because when you put code in a function, it isn't executed when the program runs unless you explicitly tell Python to run the function. To make it run, what you need to do is type the name of the function and then the parentheses. So let's go back to our editor and then we will call the function by saying sumCart and then the parentheses. Now let's have another go at running the code. And you can see now that we've called our function, we get the answer, and we get 35, which is indeed the sum of these two numbers. So our function worked. Well done, we've now learnt how to do functions in Python. So this is great, but at the moment our functions are a little rigid. Everything about the function is hard-coded into it. For example, say we wanted to use the sumCart function somewhere else in a different part of the program, but instead of adding these two values together, we had two entirely different costs that were held in different variables. What we'd have to do then is write a whole new function with the new variables written in there. And this is not an efficient solution, and it's not the point of functions. So to solve this issue, we use a concept called arguments. They're also known as parameters, and that's what the parentheses are for. An argument is a way of passing data into a function when we don't know which variable that data is going to be in. If that's confusing, let's just take the example I was just talking about wanting to add up two different costs from cost 1 and cost 2 with the same function. Let's add two more costs, 3 and 4. So we'll say cost 3 equals 5 and cost 4 equals 10. There we go. Now we're going to add arguments for the two items that we want to add up. Arguments are defined inside the parentheses, and each argument is given a name with a comma between each one. So I'm going to call them item 1 and item 2. Next, I'm going to swap out cost 1 and cost 2 for the item variables inside the function. So we change this to item and change this to item. Then finally, you need to edit the way we call the function so that we're passing in the variables. So let's put cost 1 and cost 2 there. Now what happens when I call the sumCart function is that the two variables that I've passed in are put into the arguments item 1 and item 2. This always happens in the same order you define the arguments. So in other words, the first variable you pass in is assigned to the first argument, the second to the second argument, and so on, for as many arguments as your function takes. What actually happens when the function is run is that those two arguments are made into local variables, and they are assigned to the value of the variables that you pass into the function when you call it. In this case, the value of cost 1 is put into the local variable item 1, and same for cost 2 and item 2. This means that you can easily use them inside the function. Another way you could conceptually think about this is that when you pass a variable as an argument, everywhere that argument's name appears in the function, it is replaced with the variable you pass in. So in this example, everywhere that item 1 is written, it is replaced with the contents of cost 1. So there item 1 is written, and it will be replaced with 15. So let's run the code, and we should hopefully get the same output as last time. And we do, which means our function has worked, but it's now using a much better method to achieve the same result. The difference this time is that if we wanted to add together cost 3 and cost 4 instead, we could simply change the variables that we passed in. We wouldn't have to write a whole new function. So let's see that flexibility in action now. And change this to cost 3 and cost 4. Notice the functions are exactly the same, but we can add up two different numbers. There you go, we get the sum of 10 and 5 with the same function. It's important to note that a function can take any amount of arguments, but when you call it to run, you have to pass it the same amount of arguments that you defined. Otherwise, you'll get an error. There is one way around this. You can define a default value for any argument, which is used in case you don't supply a value for that argument. Taking our current code, let's say that we want the second item to cost $5 if we don't give the function a different value for it. That's not a very likely scenario, but it'll demonstrate the concept. To do that, when we define the argument in the function, we can set it to be equal to a value, as if we were assigning a value to a variable, just like this. Now, if we omit the second argument in one of the calls of sumCart, it will fall back to the default value of 5, and this won't affect the behavior if you still apply two arguments. So let's run sumCart, just calling cost 1 as an argument, and then we'll also do it with cost 3 and cost 4, and hopefully that should work. Yeah, you can see that it does. And you can see that that works. For the first one, the two values are added up because cost 4 overwrites the value of 5. In the second one, there's no value, so it falls back to 5, and that gets added to our 15, which gives us 20 like we'd expect. So, unless you're using default values, make sure to always include the same amount of arguments as you defined in the function. Let's undo this change just to make it easier for the next part of the tutorial. There's one final feature of functions that we're going to look at today, returning values. Now, we've looked at how to make a function that doesn't mind what inputs it takes, but what about making a function that doesn't mind where it outputs to? At the moment we're printing the answer, but what if we wanted to do something else with the variable total cost? For example, maybe we want to store the first two items in one variable, then the second two in another variable. The way the code's currently laid out, we couldn't do that in an easy way because it's just printing the value each time. So just like the way we can pass arguments into a function so that we don't have to hardcode where the data is coming from, we can do the same with the output so that we don't have to hardcode the location the answer is stored. The way we do that is with return values, and I'll show you an example. In this function, I'm going to replace the word print with the word return. Now, what does that do? Well, obviously the function is no longer going to print out the answer for us. What it's going to do instead is to pass back the value of the variable total cost to wherever we originally called the function. That way we can use the answer in whatever context we needed it originally. Now, in our current program, that's not going to be very useful because we haven't specified anywhere to store it. So let's see how you store that answer in a variable. What we're going to do is when we call the function, we're going to give Python a variable which is going to store the answer. And then we're going to simply set that variable equal to our statement calling the function. So we can say cart1 equals the result of calling the sumCart function on those two values. And we can create another cart and set it to equal to adding up those two values. So then when it gets returned, total cost will go out of the function and into these new variables, which we can then use any way we like. Just so that we can see what's going on here, let's print out these variables we've just created. So I'm going to print cart1 and cart2. Go to our terminal and we can see that that works. We're still not getting any more useful output than we did before, but we're achieving that output in a much better way. We now have a function that can accept any two generic items and then return them to a variable so it can be used anywhere. We can use it in a print statement if we want, or we can use it in a completely different function. Just as a side note, if all we're going to do is print out the variables, we don't need to store them in the variables like this. We can just say print sumCart. And then the result will get returned into the print statement, which will then print them out. If we go back to the terminal, you can see we get the exact same thing. But if you're doing anything more complex than just printing, it's worth creating those variables to store them in. We've got a nice example of a function now, but it's still not all that useful because it can only do two items at a time. However, if you think back to the previous lessons on how we make lists and use for loops, then you can work out how to make this function work for any amount of costs. Remember, a list is just a variable, so you can pass it into a function the same way we did using arguments. Let's have a go at that now. We'll get rid of these costs and create a list of multiple costs. And that can have values of 5, 10, 15 and 20. So this represents 4 different items, each with a different price. Then we can modify our function to take one argument of a list of costs, so we'll call it items. And then somewhere in here we need to add them all up. So let's start by making our total cost 0, and then here we need to add them up. Then finally we can print out the result at the bottom. But this time we're just going to pass in our costs variable. Okay, so what do we need to do here to add them up? Well, we've got a list of all the different costs, and if you remember a for loop iterates over each value in the list. So when we run a for loop, we will get 5, then 10, then 15, then 20. So let's just do an example now. For x in costs, and then x will take each value in turn. Then all we need to do is add x to the total cost variable, and it will be increased by that amount each time. When there's nothing left in the list, it'll exit the function and it will be printed out. So let's do total costs plus equals x. And remember, this plus equals operator takes the current value of total costs, increases it by x, and then assigns it back on total costs. And it's just a shorthand way of writing total costs equals total costs plus x. So that's just to make your code a little bit cleaner there. Alright, so let's go and run this now. Okay, we've got a bit of an error there, and of course I missed out a 0, so I will just set that. I'm sure you guys saw that. We'll see if this has worked. There we go. We get the total cost of all the items in that list. So, since the beginning of the lesson, our function has improved a lot. It can now take any cost from anywhere in the program, it can take any number of costs from the program, and it can also return that cost so it can be used anywhere else in the program, which is much better than when it could just add up two fixed costs. That one wasn't useful at all. So you've now learned all of the most useful concepts behind functions and how to use them. So, we've seen how to make our own functions and how to use them, but there are some operations that are carried out often enough that Python has included them for use in any program. The way you call them is exactly the same as calling your own, but you don't have to define them first. We're going to have a brief look at the most important ones now, but make sure to have a look at the Python documentation because there are loads of useful functions that are available for use. The documentation can be found on the Python website. Let's look at one of the most useful functions that is included in Python, the string conversion function. There are many times in scripting when you have a variable that contains a number or some other type of data, but you need to convert that value into a string in order to do something with it. For example, combine it with other text. So let's get rid of all this and start learning about the inbuilt functions. We'll create a variable containing number 10, and then if we wanted to combine it with a message, for example, we wanted to print out the number is, and then we wanted to combine that with number, we would get an error. If we save that and run it, you can see it says it can't concatenate the string and integer objects. So that's where the string conversion function comes in handy. We can turn this number into a string so that it can be combined with our other string. So we will create the string of this number, and we'll go back to our terminal and it should run fine now. There you see, we get the number is 10, and that's exactly what we were hoping for. The string function doesn't have to take a number though, it can also take other values such as a boolean. So if we create a variable boolean equals true, and then we print out the value is, and then the string of our boolean, let's see what happens there. There we go. It says the value is true because what it's done is it's turned the concept of true into the closest textual representation it can find, which is the word true. If we try to do that with just a boolean, it would try and concatenate the concept of true and a string, which would obviously result in error because there's no way of doing that. Another common task for strings is to be able to find the length of them, and again Python has an inbuilt function for this so that you don't need to write one. Let's take the string hello world as an example and try to find its length. We'll say our string equals hello world. To do this, we're going to use the inbuilt len function, which stands for length. Just like the previous answer, all we need to do is pass it the string we want to use, and it will return the number of characters in it. So let's print the length of our string. And we get 11 because that's the number of characters. The len function is actually much more capable than this because it actually counts the number of items in the object you give it. For example, if you give it a string, then it counts the number of characters, but you can also give it a list and then it will count the number of items in the list. I'm going to move to the terminal now because a lot of the stuff we're writing now is just one-line snippets. Often in Python, you're given a number with decimal points, for example, let's say 10.6. And it's not an integer, but you need an integer to use it. The inbuilt function to convert to an integer is called int, and it works fairly predictably. It can take a number, such as 10.6, and then it will return the integer conversion of that number. It's important to note that int doesn't round the number to the nearest integer, it simply throws away anything after the decimal point. So 10.6 will give you 10 and not 11. So let's say that our number is 10.6, and then find out what our number is, right? 10.6, but if we find out the integer value of the number, we get 10. So that's how int works. The int function can also convert a string into an int data type. For example, if you had a string containing the characters 1 and 0, you could get the value 10 from that by running it through the int function. So if we do string, we can see it's a string containing those characters. But if we do the int of this string, we get the number 10. And then you can add stuff to it, take away, do any of the mathematical operations, because it's now a number. Be careful, because when you're converting from a string to an integer, int will not handle decimal places. For example, if we set string to equal 10.6 and then try to call the int of string, we'd get an error because it can't pass the decimal number to an integer. Alright, as a final look at the inbuilt functions of Python, we're going to take a quick look at the range function. The range function comes up surprisingly often when you start doing more complex things in Python, and while it might not seem massively useful at the moment, it's worth having a look at and getting to know how it works. Range is a function that you use to create a list of numbers following a certain pattern. The simplest example is perhaps that you need to create a list containing all of the numbers from 0 to 10. Instead of typing that out manually and then allocating the memory for the list and then using it, you can simply use the range function to do it all in one line. Range needs you to pass it an integer, and in this case we're going to need to pass it 11. Because what range does is it starts at 0 and makes a list counting upwards until it hits 1 less than the number you put in. So if we want our numbers 0 to 10, we can do range 11. And there we go, we get the numbers 0 to 10. Starts at 0, counts up, gets to 1 less than our number, and stops. What about if we wanted to print out the numbers from 5 to 10 instead? Well, we can include an optional argument, just like we learnt about earlier, for the starting number, and this will print out the numbers 5 to 10. So if we print out the range of 5, 11, you can see we get the numbers from 5 to 10. Starts at 5, counts up, 1 less than 11, and it stops. The final part of the range function is that it can take a step value, and that is how much it jumps up each time. So each time here it's jumping up 1, but what if we only wanted to print the odd numbers under 10? Well, range accepts this step value. So if we start at 1, set it to step up 2, and then the upper limit of 11, we should get all the odd numbers. So let's do range of 1 to 11, and go up 2 each time. And there we go, we get all the odd numbers below 10. Just as a final note on the range function, any of these numbers can be negative as well. So if we wanted to count down from 10 to 1 instead of up, we could set the step to be negative 1, and the starting to be 10, and the limit to be 0. So if we call range of 10, 0, and negative 1, it starts at 10, counts down, negative 1 each time, and then stops before it gets to 0. A final note on range is that it will only deal with integers, so be sure not to give it any values that aren't that, or you will throw an error. Alright, that's as many of the functions as I'm going to show you for today, because there are hundreds and hundreds of inbuilt functions in Python, and it wouldn't be a very interesting video tutorial to just go through listing them all. The important thing is that you now know the concepts behind them and how they work, so you now have the base knowledge you need to go out and find out about the rest of them. A lot of them are pretty obscure and you might end up never using them, so there's no point me teaching you about them now. All of the functions in Python are documented on Python's website, so if you want to go there and look up the thing you're currently trying to do, then you should find a function that does it, and you'll know how to use it from the skills you've learnt in this lesson. For the second half of this lesson, we're going to move on to the concept of modules. If functions are groups of code, then modules are groups of functions. There's more to them than that, but you can think it's a good way to think about them for now. As we discussed earlier, you can't make a complex program without sorting code into functions, and as your program continues to grow further, even they can become unwieldy. If you had one script with 200 functions in, it would be very hard to find the one you were looking for by scrolling up and down. So you can sort them into another hierarchical level, and these are what modules are. So we can summarize them as a structural and organizational tool for our code. Modules are very easy to create. All they are is Python files, just like your regular scripts. To make a module, all you need to do is write one or more functions in a text file, save it with the .py extension, and then import it into a script to use it. So I'm going to do that now with an example. Open up a new file in your text editor and let's make a function. I'm going to continue with the example of a shopping cart from earlier and make a function that calculates the tax on products. So let's define a function called addTax, and it will accept a price and a tax rate variable. Then we'll create a variable called newPrice, which will be set to the price divided by 100 to get 1%, and then multiplied by 100 plus the tax rate to get the new value. Then we're just going to return this new price. So nothing new here, this is all stuff we've just learnt in the first part of the lesson. Okay, I'm going to save that, and I'm going to give it a name. I'm not going to call it functions or anything like that, because that's very bad practice. The whole point of modules is that it allows you to make your code much easier to sort through. So if you just create a big text file with 100 functions in, call it functions.py and save it, then it's not going to make it any easier for you to find what's in it. However, if we had 10 other functions all to do with financial operations, then calling this function finance would make a lot of sense, because then when we had a massive project in a year's time when we were looking through, we'd know exactly what this module, what actions this module performed. So I'm going to save this file as a file called finance, and this is now a module, if we want it to be. Just as there are a lot of built-in functions, there are a lot of built-in modules. Every good programming language has a lot of built-in modules, but Python really excels here. It takes what's called the batteries included approach, which means that there are a lot more modules included with your download of Python, which means that you don't have to go out and look for modules to download and include. It's already there in the standard library that comes with Python for you to use. So because Python has such an extensive inbuilt library, just like with the functions, there's no way to cover them all, and again, some of them are quite obscure and you'd never need them. So I'm going to cover a few of the most useful ones, and then you'll know the concepts behind them, so you can check out other ones on the website as and when you need them. In this lesson, I'm going to cover the math module, the random module, the DateTime module, the OS module, and also the URL lib module, which is used for interfacing with the web. So to use modules, we can use either the import or the from keyword. Import is the simplest and the most common, so let's try that first. You first specify the name of the module, which is simply the file name without the .py extension. So if we wanted to import this finance file, we could just go import finance. It's as simple as that. And notice they're in the same documents directory, so it will be able to find it. If it's in a different directory, it's a little bit more tricky. What this does is it makes it like all the stuff that's written in here is now written in here. You now have access to all of the functions in this script. This means you can then call them just like they are in the regular script. You can also use the from keyword, which allows you to select specific functions from the library if you know which ones you need beforehand. For a module that has hundreds of functions, this is recommended because it saves loading time on functions that otherwise aren't being used. So we can do from finance import addTax. So that doesn't do anything different at the moment because we've only got one function in there, but if we had another one, for example calculating the discount on a coupon code on a product, then it would only import the tax function. However, if you don't know which ones you need beforehand, then you can just do import just write import finance and it will get it all for you. You can also import several modules by separating their names with commas. So we could do import add tax and calculate discount, and then we'd have access to both of them. But that doesn't exist yet, so we'll get rid of that for now. In fact, we'll go back to just importing our finance module. After importing the module, to use the functions contained within it, you use the module name followed by a dot and then the function name. So to use the add tax function, we can do finance.addTax. And then, just like a regular function, we do our parentheses, and we would have to pass in the price and the tax variable. So let's try that now. Let's run a function which takes the product which costs $100, and there's a 5% tax added. Obviously, the final thing we need to do is print out the value it returns. So we will save that and go to the terminal, and then we'll run through the script. And there we go, we get 105 because it's added 5% to our initial cost. And as you can see, nowhere is that code written in this file. It's being imported from here. And you have now got a working module. If you find someone else's code on the internet that you want to use, it will almost always be in the form of a module or a library of modules. Download the file and then import it like any other that you write yourself. Some will come with an installer that does the work for you, and as long as you have Python installed and the library is compatible with your version of Python, the import line will work no matter where your script is. It's not directory specific like these ones are. Let's have a look at some of the inbuilt modules. A good one to start with is random, because it's easy to understand and it's also very useful in a lot of scripts you'll write. As you'd expect, this module lets you generate random numbers, or pseudo-random numbers, that are random enough for the purposes of most applications. For example, when using Python to create a website, they can be used for making your password database more secure, or perhaps for powering a random page feature. So, if we want to create a random integer, for example, we can use the randint function, which is in the random module. So, at our Python prompt, let's import the random module. Then we just need to call random.randint, and it takes exactly two parameters, a lowest and a highest number. So we should get a random number between 0 and 5. And you can see every time I call it, it's picking a new random number for me. If you want a random floating point number with some numbers after the decimal place, you can use a function called random, same as the module. So now we've got random imported, we do random.random, and this doesn't take any arguments, it simply generates a random number between 0 and 1. And there we go, we're getting a lot of decimal places. If you want a larger random number, you can then just multiply it. So we do random multiplied by 100, and that'll give us a random number between 0 and 100. And because it's got so many decimal places, it's you can still shift it up and have a lot of decimal places left to use. So there we go, we're getting random numbers between 0 and 100. And you can multiply it by whatever you like to get a random number up to that with decimal places. Okay, so just one more function in the random module to look at today, and that is the choice function, which allows you to select a random element from a sequence, such as a list. So, for example, if we had our website and we had maybe a list of users, we could say users equals John, Joe, and Jim. We could then select a random user by running random.choice on our users list, and then if we kept running it, we would get a randomly selected one. The random module contains a lot more functions for working with different things, but they all work around the same concept. So yeah, go check that out if you need to find out more. Okay, so the next module we're going to look at is the math module, which, as you'd expect, provides access to lots of mathematical functions and constants. It's not especially tailored for building websites with Python. It's more useful for something like video game design or physics simulations, but it's still a core part of knowing about Python and something that it's definitely worth looking at. So we're going to take a look at just a few of those today, just very briefly so you get the idea. If you import the math module, you have access to lots of constants, so you can get something like math.pi, gives you pi, and you can get Euler's number with E. You can get some trigonometric ones, for example math.sine of an angle, and it's got cosine and tangent as well. There's functions for converting angles, so we can do degrees of 2 radians, or we could do radians of 60 degrees. You can do factorials with it. The factorial of 5, which is 120. If you don't know what factorial is, it's the product of all numbers up to a given number, so that'll be 1 times 2 times 3 times 4 times 5. It can also square root numbers, so you can do math.square root of 49, we get 7. And it's got some logarithmic things. For example, you can raise Euler's number to a particular base by doing math.exp of 5, which is e to the power 5. So a lot of handy things if you're doing any sort of mathematical calculations. Okay, moving on again. Another really useful module is the Python module for interfacing with the web, and it's called urllib2. And if you're doing any web design with Python, it's one you're going to be using really often in pretty much every script you write. So we can get at it by doing import urllib2, and we have access to all the functions it contains. Pretty much the most useful one is one called urlopen. So we can run urllib2.urlopen, and it accepts a string of a website address. So I could just use my website as an example. And then it will download the HTML content of my website, ready to be parsed, and you can get data out of it. You're basically just sending a HTTP request. It's important to notice that this doesn't return a string, it returns an abstract object containing the data, and if you want to get the text out of that, you have to use the read method to loop through and access it. So if we get this object here and then call the read method on it, it should read it all, but that would just dump the entire thing. You can pass in a number here of how many characters. So let's read the first 100 characters from the text of my website. And there you go, it downloads it, and that is just the doc type declaration of my website there. And you can run that on anything. We could run that again, and we could pass in Google. There we go, that's the first bit of Google there. We can get more characters of it. That's a lot more, and it obviously looks like garbage here, but then you can process through it and get all the useful content out. And in later episodes of this series, when we're looking at how to actually build websites with Python, then that's something we're going to be doing. The urllib2 module obviously contains a lot more functions, but they're mostly getting a little bit too complicated for the level we're currently at. A lot of them are object-oriented, and that is something we're getting into in the next lesson, so we will definitely come back to this module later, but at least you know about it for now, and you've got an example of obviously the most useful module in there, the most useful function in there, which is the urlopen one. Okay, just going to cover a couple more modules, and then we will have learned all we need to know about modules and functions in Python. We're going to look at DateTime and the OS module. First we'll do DateTime. DateTime is pretty self-explanatory. It contains functions for handling dates and times. So let's have a look at it now. Just create a new tab because this one's getting a bit messy. Go into Python and import the DateTime module. Now this doesn't actually give you access to everything because there's also a time module which contains some of the other functions for handling time specifically. So we can import time as well, but you don't need to think of it as a separate module. It's all in the same field of they're all related to each other. Also, most of the operations you do with the DateTime module are in a date submodule. So instead of having to type out DateTime every time, we can use the trick we learned earlier and go from DateTime import date, and then we get access to all of the date functions there. So there's a lot of useful functions we can look at here. For example, time provides access to a time function which returns the current time from the Unix epoch in seconds, and that is obviously January the 1st, 1970, and that's the number of seconds since then, and this is I guess this is milliseconds and microseconds as well. That particular function isn't particularly useful to us because, you know, that's not user readable. Luckily there is a function though that can convert that into a readable date. So we can do date dot from timestamp, and then we can pass in our timestamp, and we could just type a number here. So we could do date from whatever, that many seconds, and that would tell us what it was then. Or we can get the current time using the time module right there. And as you can see, this is returning a DateTime object which contains the date that reflects. Date also contains a from ordinal method which returns the date a certain number of days after the year 1, so 1 AD. So we could say, you know, 10,000 days maybe. And that would be the 18th of May in the year 28. There's also some functions for formatting these dates into nice readable strings. So if we say current date equals our date from timestamp time.time, then we can just check that current date has got that. There we go. That's not actually a string, that's a date object containing the data. So we can get the string out of it by running a function which gets a string, and it's called string f time. So we can do str f time, and then we can pass in a string which has the format. And the format string contains several special characters which can be used to signify it, and they're preceded with a % symbol. So we can use D for day, or we could use Y for year, and then obviously you can combine them with special characters in the middle. So if you separate your dates with slashes, you could do day / month / year, and that would format it like that. Or if you separate it with dashes, you could do that, or colons, and you could obviously miss out the year. There's a lot of flexibility there in how you format your dates, and this is obviously very useful for something like a comment system if you're getting the time a user posted a comment and printing that out. This is a module that you'll end up using quite a lot with when it comes to web design. There's also another function which automatically puts it in ISO format, so we can do current date.iso format. Alright, we're going to look at just one more module today because I realise there's been a lot to take in. This last module is the OS module, and it provides access to lots of underlying features of the operating system. So let's create a tab, go into Python, and then we will import OS. Now OS contains a submodule called path, which allows you to access lots of things to do with files and folders. So we can do from OS import path, and we have access to all of those. Now these are all very useful if you're running a website, if you want to access some of the files on your server. For example, if you're loading up images to display or saving those images, or you've got configuration files, or if you user uploads, storing those somewhere. This is very useful for getting the paths to manipulate for that. So it's something very relevant to web design that you'll want to learn. So we'll take a look at a few of the methods in it now. A very useful function is the exists function, which derives from path. So we can do path.exists, and we can put in a path. So if I do the users folder, we can see that that exists, we get true. But if I just put in random folder that doesn't exist, it gives us false. We can do users and then my users folder, which does exist, but there's no one called Bob on the computer, so that's false. There is a function for accessing the last time a file was modified, which is useful if you want to get, for example, the most recent image for a certain page on your website. You can use path.getAtime. I think A stands for access time there, and we could pass in users again, and that's obviously that's the number of seconds from the Unix epoch till the time when it was accessed, and then you could obviously convert that using some of the DateTime functions into a usable string for when it was accessed. So you're seeing how all these modules now can tie together and complement each other. There's another one very similar to this for when it was last modified, not just accessed, so the last time a change was made to it. And we can run that, and you can see that that's a slightly different time. The last time a file was saved in the users directory. There's a useful one called getSize, which returns the size in bytes of a particular file. So I'll do path.getSize, and I will go for users Giles desktop, and I'll just pick a random file on my desktop. I think I've got a boot file there that's got an easy name to type. There we go, that's the boot file, and you can see that it is 314,000 bytes, or 314 kilobytes. The OS module also contains a function for joining path names, so we can do path.join, and we could take the C drive and then combine that with our users folder, and then it would give us that. Now you may be thinking, why don't we just type that all as one string or concatenate the string? Well, it's different on every system. If you wanted your Python script to work on Windows and Mac and Linux, the path names are going to be different. For example, Windows uses backslashes to separate folders, so that wouldn't work. This path.join is cross-platform and compatible wherever you want to use it. And also, if you are returning your drives from a different method, you've got a different function that gets you a path, and you want to combine it with another path. Instead of just adding up the strings, you would use this because it's specifically designed to do that and make sure it's compatible. The OS module also contains a lot of other stuff. For example, you can get information about programs that are currently running on the system and how much memory they're using and things, but that's not something that's going to be particularly useful for us in web design, so I'm not going to bother looking into that today. Okay, so we've taken a pretty good look at functions and modules in Python, and you've learnt how to create your own, and also how to use some of the inbuilt ones and the functionality they offer. Just before we finish today, I want to cover two little extra things that aren't necessary, but they're a nice little bonus and make your life a lot easier. They're not specific modules, they're just tools to do with using them. The first one of these is assigning functions to variables. Now, a lot of these functions that we've got have quite long names, and it can get tedious if you're typing it out many times, especially if it inherits from a module and you've got two things to type out. So, for example, if we import random, if we're calling random.random a lot of times, that would get tedious to type out in your script, and you can make it a lot cleaner by assigning this function to a variable. You can do r equals random.random, just like that, and now r is equal to that function, and you can call just r as a function and it will perform the same thing. And you can see now you've made that a lot smaller. So that's a very useful tip, especially if you're importing from modules with long names and you're ending up with a really big string that you're repeating again and again. It also works with functions that have arguments. So if we were doing math.square root, like we saw earlier, that would accept an argument. So 49 was the example I used earlier. You could say that s equals math.square root, and then you could call s the same, s of 49, and that would return the same thing. So that's a useful little tip to know for making your code a little bit cleaner and smaller. just look, if you notice the syntax here, you don't actually put the parentheses afterwards, you just put the name of the module and the function, no parentheses or anything else, because otherwise you'll get an error. The second thing I wanted to mention at the end is how to access modules that are in different folders. I've touched on this a couple of times earlier in the lesson, and if a module is in a different folder to the one you're running, it can cause a few more problems. So you can have, the ones we've been doing, it's been either in the same directory, the documents directory, or it's been the inbuilt modules that are available everywhere. But if you want to have your folder if you want to have your module in a different folder, it's a little bit more tricky, but I'll show you one way of doing that now. There are a couple of ways of going about this, and one of them is to turn the folder into a package. And a package is just another level of organization. A package is a folder containing lots of module files, and then you can import the folder, and it imports all the modules and then all the functions within it. So it's just another level of organization for your code. And in Python, to turn a folder into a package, you have to create a special Python file in it, which tells Python that it's a package. So I've just created a sample here. If we had a script file and then this subdirectory, and then in there we had a module that we wanted to access, we would have to create a file like this, and you give it 2 underscores, then init, and then 2 underscores. And this file can be completely empty. What happens is it is run before, when you import it, this file is run before any others are run. So you can use it for setting things up. Or you can just keep it completely blank, have it not do anything, but it turns this subdirectory into a package. So then from script, you can import my module, even though it's in a different directory. So if we go and open up script in a text editor, so in our script file we can import subdirectory.mymodule, and then we have access to that module even though it's in a different script. If we access my module and we define a function, let's just create a function called greeting, doesn't take any arguments, and it prints hello world. There we go. Then we can run it by doing subdirectory.mymodule.greeting. I think that's what it's called, yeah. And then it doesn't take any arguments. And that should work. So let's go to the terminal, create a new tab there, and I'll change to my documents directory, then change to the lesson 3 directory, and we'll just list the files, and there we go, script. So we will use Python to run that. And you can see we run that script and get hello world, even though it's in a completely different directory right there. So that is one way about accessing files from another directory. You can store them, you can use this init file to turn it into a package and then run it like that. There are other ways of doing it, but they're a little bit more complicated, and this is probably considered best practice, so we might have a little look at them in later episodes. Alright then, that just about does it for today. We've learnt a lot about functions and modules, and if you've made it this far and understood everything, then well done. And if some of it's gone over your head a bit, then just watch the video a couple more times and I'm sure you'll get the hang of it very easily. Next lesson we're going to be learning about object-oriented programming, which is very challenging, but once you get the hang of it, your code is 10 times better than the stuff we've got to at the moment. So be sure to come back for that next one. And if you've got any comments or questions about the stuff we've learnt today, then as always I'm more than happy to answer them in the comments. Thanks very much for continuing to watch this series, and as always check back to net.tutsplus.com for the best development tutorials on the web. I'm Giles Lavelle, thanks so much for watching. See you later, bye.